Hey everyone, welcome to session 2AC, innovative, open and automated testing for your zOS applications with James Davis, the world-renowned James Davis.
Yes, incredibly famous, right?
Incredibly, if you've been to a meetup in London and shared pizza and soft drinks.
So, we are at the hour, so I don't know if you want to give it a couple of minutes or do you want me to get going now?
How long are you going to take? The full hour?
I've not got a huge amount of slides, but I've got quite a lot of demo material that I'd like to get through. So,
in that case, I suggest you crack on. So, just for anyone late that's joined, you are in session 2AC. Don't forget about the feedback, and I'll now hand it over to James. Good luck.
Yeah, thank you very much. Yes, I will flash up a slide at the end with the QR code and session number on again. So if anyone doesn't remember it as we're going, don't worry about it. So hello and welcome and thank you for coming on to this talk about zOS testing and how we can automate that integrated level of testing through your zOS applications. So I'm going to flash a quick, with my keyboard listen, there we go, phrase on here that hopefully if you don't relate to this, you can at least appreciate the fact that automating your integration testing is hard. It's not a trivial process, and it's something that we commonly receive feedback from, a plethora of clients and locations and whatever about the difficulties about this automation of integration level of testing, because this stuff is normally done manually. So if we dig into, well, what are the reasons? What are the feedback that we're hearing coming back to us and telling us? And one of the number one comments is just a lack of tooling and support for zOS. Whether this is just in terms of, do I have 3270 interaction? Can I submit batch jobs? Can I interact with, zOS files and data sets? Or if it's a bit more high level than that, how do I interact with a piece of middleware, etc.? But we also have a requirement in integration testing to be looking at just more than a little bit of code. It normally involves a bit of infrastructure as well. And that requirement within a test that has the possibility to be spanning multiple platforms from a single class starts making the code look rather complicated. So for example, if I had a test that not only wants to connect up to a zOS region via 3270 and also maybe submit some batch jobs using zOSMF, but what happens if I want to actually then start interacting with a cloud application as part of it, because maybe my application spans multiple stacks? The test starts to look more and more complicated. Next problem we always hear is execution and management, because it's one thing to write a test and have maybe a script that can do a piece of work for you. It's another thing altogether to be concerned about its execution, the runtime which it is running in, and also how do I manage the tests? So when we come to our testing phases of our delivery, how do I know what tests have been run, and how do I know how I'm confident that everything is passed and I'm happy to go ahead and deliver? And then the last point on here is that support for multi-platform as well as CI/CD tooling. Because as we progress into this future of making everything automated and having the pipelines and this continuous delivery when I'm putting in change sets, I need the tooling that I need to work with my zOS, so my batch and my 3270 interaction, to have a native understanding and native fit into a CI/CD pipeline. So for the rest of this presentation, I'm going to work with a demo and an example, which I've put a very quick description here of the general architecture of how it works. So the actual application under test here is a very simplistic banking application that we call SimBank. And it has a web front end, which a user can come along, type in their account details, type in an amount they want to accredit to their account, and actually push this through the web browser. This then interacts with a cloud-hosted web server, which obviously serves up all the thing that the browser sees, but it also communicates with a Kix application, which is our system of record. So we want to be able to test this application. And if I'm sitting down and pondering around and thinking, right, what do I actually want to test? And the big thing is I want to make sure if a user comes along and makes a change on the web browser, that every step of this, application that we look through on the diagram here is working. So the data that is interacted with on the web browser, it makes it to the system of engagement right at the bottom there. So if we break this down into several smaller chunks, we can have a look at the web browser. I want to be able to simulate a user's interaction, whether this is just filling in some fields, typing in some data, and hitting send. And there is plenty of tools in this area for being able to achieve this. One of them being like Selenium. Another one that I've seen recently is Cypress. And they allow us to drive web browsers, whether this is going to be Firefox, Chrome, Opera, to simulate what a user's interactions would be. So maybe that's something that we're kind of comfortable with. The cloud-hosted application, however, might actually just be a containerized application. So my containers team might come back and say, here's a Docker registry that has the latest version of the application, this web server, and you can go and host it in a Kubernetes namespace that you use for testing whenever you want. And if you just use the latest flag, you will always be pulling the latest version. So that's obviously a very different thing to how we want to interact with the web browser. And then things get even more complicated. Then we want to start involving our zOS regions and our LPARs. And we may just have a test environment. So we're given an LPAR that has a Kix region on it, and we're so that we can go and deploy and use that application every time we have a change set to perform some testing. So when we start to consider the automation points here, there's a lot of problems and a lot of questions that start coming up. So the top one on that right-hand side is, how do I provision some of the components and bind to others at test time? So what that really means is, how do I bring up a Selenium WebDriver and have it interact with the correct version of the containerized web server that I'm going to bring up on the fly as part of the test? How am I doing that binding piece? And it's the same between the cloud-hosted web server and the backing zOS LPAR and Kix application. How am I making sure that everything is configured at runtime of the test to make sure that we're plugging into the right environment? And then I've got, how do I drive these interactions between each layer? Because these are some very different technologies. A Selenium test can be written in Java, which would be really nice. But how am I going to make sure that I'm driving the web service endpoints on the Kix region in the same test that I'm bringing up Docker containers and driving Selenium drivers? You're starting to interact with a lot of different technologies in a single test class. And then the last one there is not always something that people think about straight off the bat. But as we move into this world of having things delivered in a continuous style, we start parallelizing workloads. So how do I ensure that I'm the only one that's going to be using these resources? Whether this is a piece of data that I'm actually going to be driving an account from the web front end all the way to the backend database, or whether this is just, I want an exclusive lock on this zOS LPAR that we're using. So as you might be expecting, this is where I come along and say, don't worry, we've got something just for all those problems. And if you haven't heard of us, I would like to introduce the Glasser Test Automation Framework, which, as it says on the tin, is a framework designed to help you automate the testing of, well, we do say our zOS applications, but it is a hybrid cloud applications and hybrid cloud infrastructure. It has this modularity to it with an extension point that we call managers that allow for this easy integration with lots of different test tools, lots of different technologies, and lots of different platforms. And at test runtime, you can use the managers and these extension points as you see fit. You don't need to be instantiating the lot of them. You can just cherry pick. So let's say I just literally want to write a basic test which has some interaction with batch. I can just use the zOS batch manager, which will allow me to submit some batch jobs really simply. It allows a single test case to interact with multiple platforms, multiple technologies, but more importantly, in a very simple way and in a consistent way. Because there's nothing worse than when I'm interacting with lots of different technologies in my test class, and they all have their kind of nuances about them. And like, you have to provide your API in this format and so on. Glasser looks to provide all of the technologies it interacts with in a consistent manner. And hopefully you'll see that when we start looking at a test in a minute. And when we start progressing forward and moving this into pipelines and automation, Glasser also provides that isolated environment and built-in resource management to allow you to get to that enterprise level of horizontal scaling, allow you to run the hundreds of tests in parallel if you have the infrastructure for it, without the concerns that my test is going to start colliding and making a mess of my infrastructure. So I've kind of talked the talk about what Glasser does very briefly there, but I think it's just going to be a lot more poignant if we actually just jump straight into a demo to show exactly what's kind of going on. And I wanted to start off the demonstration actually showing you maybe what the user sees. So this is a very simplistic application, and I wish my bank account worked like this, because I can type in an account number here, and I can type in an amount of how much I want to credit to that account, and I could submit that, and we would see a credit account. But if I was actually doing this test properly, I'd have to first log on to our region. So I'm going to do that now. Access the application that we need to go to. So I'm just going to really quickly do that. It offers me to browse some accounts here. So I'm going to go and have a look at the same account there, which is 1 to 9. We can see that account exists, and it has 56 and 72 credits inside of it. And this is really good, but what happens if there is a team of testers right now and I don't know which, who's using which account? Maybe I have a spreadsheet, but there's always that chance that someone's forgotten to update the spreadsheet, or and so on. I've got to deal with this account number. But anyway, if I hit submit here, hopefully we see some validation comes from the checkboxes, and I get a little message to say, you have successfully completed the transaction. So if I come back across to my terminal over here and update, we can actually see that my credits went up by 200. Fantastic. So that is the manual approach to the test that I want to automate now. And not just automate, improve, because I'm keeping in mind the fact that I want to be moving these tests into a hugely parallel environment. Oh, wrong way. So I'm going to jump into an Eclipse session here. And I have got a test class in front of us. Let me just make it a little bigger. Is the text size good enough for people, if someone wouldn't mind just unmuting quickly?
I can't unmute, but if you could type in the, yep, good for me, says Sophie.
Oh, perfect. So we have a test class here, which is going to perform that test case that we would just manually performed. I have minimized some of the code so we don't get caught up in it, but I've highlighted certain aspects which I want to go through now. And it starts off with the annotations at the top of the test class. Because remember I said that Glasser offers these very consistent way of interacting with resource in a test class. It's these annotations that provides that interface to the tester. So for example, I can see that I've got a zOS batch object here, which I have loosely tied to a SymBank image. So if I scroll down, and because I know that this batch manager is used in this method here to open an account, I can see it's very simple to go away and submit a batch job. I've got zOS batch job, and I submit a piece of JCL, which I filled in at runtime because I want to pass an account number and I want to providing an opening balance. I fill those parameters into what we call a skeleton piece of JCL, which I can show you here, which is not particularly exciting. Where we fill in the control and the data in. And this is exactly what these parameters here are doing. And then we can just submit that job. I've not had to be too concerned about where's the endpoints. I've not even had to be concerned of what's the implementation of how I'm submitting that batch job. Am I using zOSMF? Am I using RSE? Am I just doing an OMVS logon and submit command? There is lots of options on how I could submit a batch job, but it has been extracted away from the tester so they can exactly identify what they're trying to test. So I want to submit a batch job. I'm not being concerned about the implementation behind it. What the Glasser framework is doing at runtime is using provided configurations, it is binding to the correct environment and allowing this test code to be executed in the correct manner. So let's say I wanted to move between, a test environment and a production environment, which use 2 different implementations. I don't actually have to make any code changes for the test to be valid in 2 different environments. So let's just close that down. So I've got a few annotations at the top here. We've got like zOS ones. I'm going to come back to these ones that are labeled SymBank because these are something specific called an application manager. But we've got a list of managers here, which at WebDriver is the Selenium manager, which is going to provide me that interface to interact with a web browser. And bundle resources is so I can interact with that piece of JCL. And I've also got a HTTP client. And I'd just like to highlight here, if you're a Java developer, you might be going, well, it's not hard to write a HTTP client in Java. I could definitely do that myself. But it goes back to that consistency manner. We want to be able to interact with all of these technologies in a very simplistic and consistent way. And we're abstracting that complexity of maybe the different ways we could do it out of the test and into the Glasser framework and the managers that is provided for it. So I'm not going to do much more talking on the test code. I'm just going to go away and submit it, and hopefully it passes. I'll try and talk through it as we're going, but at the minute the Glasser framework is starting up. The eagle-eyed amongst might see some 3270 screens flying by. The output at the minute is currently mentioning that it's starting up a Docker container inside a cloud environment, which in this case is actually just my laptop, but it could have been anywhere. And we're now going to be submitting a few batch jobs. Hopefully on screen in a second, you'll see a web browser open. Ta-da, almost like planned. And we got a connection was reset. Fantastic. So unfortunately, my laptop doesn't like sharing screens and starting Docker containers. So I sometimes get these connection resets when I'm under a lot of performance. We're just going to try running that one again because sometimes it works a lot better the second time. But I promise this is based on my laptop's performance, not the actual framework itself. So we will give it a second chance. Now it's warmed up. So we're hopefully starting up that container again.
Oh God.
Did someone have a question then?
No, I was just saying the demo gods, James. It's always.
Oh, I know. I obviously didn't make enough sacrifices this morning. So I said we'll give it a round 2. If not, I can always show some test runs that I did do earlier. So, we've still got a connection reset. Yes, it's really not enjoying the performance of my laptop right now, unfortunately. But let's pretend that message said passed, because thankfully I did run this test this morning and I can show you what kind of happened then this morning. So, which is runs 55 there. But if I just refresh this view to show that we did just run it a couple other times, I am going to admit I'm just going to open up the past one so we can actually have a look at what went on. But we just ran a test then, and hopefully it should have done everything that I did manually. So I have access to the run log, which we could scroll through and have a look at all the screens that we touched, and we could have a look at all the other objects that were provided. But Glasser actually provides a really easy interface to interact with some of the test resources in a much simpler manner. And we call it the stored artifacts view. And this is a really key piece which brings a lot of value to anyone that's working in diagnosing what's going wrong with a test. Because all of a sudden, every artifact and every piece of technology that I'm interacting with as part of a test is available from a single location. And this works even if I'm actually working in a team environment. So we're running locally on my laptop right now, so we won't be able to explore that. But what would happen if I was running this in a production style environment with a team of testers is my runs here would be running probably in a logically isolated environment in something like Kubernetes, but they would also be accessible by anyone in the team. So if I said, oh, do you mind going to have a look at what went wrong with U55? Someone can have a look at the ecosystem and then log on and have a look at the run log and have a look at all the artifacts that we got back. So for example, let's just open a few of them. We can have a look at the terminals that the screen went through, and we provide an in-house viewer so you can click through all the screens and see exactly what went on. Same as for the batch job, we could actually have a look at the whole spool output. So I've not had to go and log on to the system to get this. I just have complete access to everything that we've done inside of this test from my IDE, which is just a time-saving, lovely thing. So we have access to multiple bits of technology. So I'll show you some zOS ones there. I could technically show you the web services just to be, show you everything, and even the Selenium screenshots. So what we should have seen on that browser was something, click on that looks a little bit like this, the pictures that we saw manually. I would also just like to point out, actually, I'm not going to point it out yet. I'll come back to it because I do have a second demo coming there. So I'm going to flip back to the slides now. Here we go. So after that unfortunate demo, I'm really nervous the fact I've got 2 demos, and demo number 1 didn't go particularly well, but let's we'll soldier on through anyway. I want to take a step back from the test code now, because I think it's important to highlight the fact, how do we go about running Galasa? What we just saw with me playing around with my laptop was actually more indicative of what I've got in the very first box here, which is a proof of concept. Because all the configurations and all the environment setup, I've actually just got locally on my laptop because I wanted something specific for today's demo. It's very lightweight and it's very easy to instantiate. It actually makes it really nice to get up and started. We have tutorials on our website, https://galasa.dev, which takes you through the process of working with a basic application and getting a test running within a matter of like half an hour. So it allows you to bring up very easy proof of concepts that run locally on your laptop and have all the configurations on your laptop for very just, as I say, proof of concept. The next 3 boxes, however, are probably more indicative how I would expect someone to be using Galasa in a real team. So we still have this concept of a local run. It's very nice if you have it established with a Galasa ecosystem, because it allows minimal changes from my perspective as a tester writing some tests. It still runs, I say, on my laptop locally. So what I could do is I could add breakpoints to my test code and I could step through it as I'm either debugging or even writing tests, which allow me to get that, really kind of deep integration of my testing, but it feels very close to my laptop, if that makes any sense. I'm interacting with real zOS regions and submitting batch jobs and interacting with 3070 screens, but I'm not having to leave my IDE and I can step through it in a local way. We then have the ecosystem way of running Galasa tests. And this falls back into the enterprise scale now. This is when we want to run not on a laptop one at a time. This is when we want to start running tests in logically isolated environments, whether this is just in a Docker container or whether this is in a Kubernetes pod. But it allows us to submit tests and run them in these environments. It also offers us, as put here, to call upon a catalog of tests, which is great because we don't need to have all the test material locally. We don't have to compile it. We can just ask the Galasa ecosystem in a real testing as a service style to go run me a set of tests without having to, clone down the test material, compile the test material, submit the test material. It's none of that. It is a catalog of tests which I can call upon at any time to submit and do some quick validation. And the last box here, I've labeled automation, but maybe there's some better terminology for it, so maybe pipelining. But this is the true testing as a service now. So, I have my continuous delivery, my continuous integration pipeline set up, whether this is Jenkins, whether this is in something like Tecton, GitLab, Azure, it could be anything. Because the Galasa ecosystem offers a very simplistic REST endpoint, which can either be called from its REST endpoint, but also from a CLI tool that we offer, to allow you to integrate Galasa into any CI/CD pipeline. We're not adding strict limitations of like, we have a Jenkins plugin, which we do have a Jenkins plugin because that's what we originally started with. But we decided to take a step back from that because we find that a lot of people bring their own CI/CD technologies, a bit like the bring your own IDE kind of movement. It's the same kind of idea. So we provide the tooling and the pieces that you need to be able to integrate it into any CI pipeline. So I badgered on a couple of times then about the Galasa ecosystem. I didn't give any context to it, so I just want to very quickly do that now. And at a really high level, the Galasa ecosystem is just a set of microservices which literally just manage the Galasa runtimes. And when I say the Galasa runtimes, I don't just mean the tests, because the Galasa ecosystem has some more complicated pieces in there. So I hinted at before that we have resource management. This is one of those microservices that runs inside the Galasa ecosystem. So we can run it in a kind of Docker environment. So I could bring up a virtual machine and just have all these services brought up on that using the Docker operator. But I can also launch this just as easily in a cloud environment like Kubernetes or OpenShift. And it then provides this lovely black box for me to submit testing to, whether this is from my IDE, sort of in my Eclipse, I want to call upon that test catalog I discussed and submit a bunch of tests, or whether this is that pipeline that's going to be using the CLI tooling to submit some tests, or even just directly submit them to the REST endpoint. But what do I get from my Galasa ecosystem? What am I getting out of just, right? Why don't I just sit on my laptop, write some tests and submit them when I want to? Why should I bother moving towards this, larger scale infrastructure? Because this does require some commitment. Well, one of the more what's the word? Not the word, not great things. Convenient things is a team-wide level of configuration. So I've not shown it in any of the demos today, but we have something called a configurational property store. And this is where we start tying the loose tags from a test. So in the test, it said something like Symbank into real systems, because I want to have things like host names. I want things like port numbers. I want to know which credentials to use. These kind of configurational properties I can manually configure on my laptop, and I can even override stuff that I find in a ecosystem. But if I provide a basic set of configurations within my ecosystem, my entire team is singing to the one source of the truth. They're not having to go, oh, have you pulled the latest changes? Because I made some big configurational changes yesterday because we moved our test LPAR onto a different LPAR, and I need you to know. There's none of that. Every time we run a test, we pull down the configuration from the ecosystem. Resource management. This is a big one, because when we talk to testers, they love to break things, and this includes the testing tools. They have a real affinity for wanting to push the big red button at the most inconvenient times, which, when we're talking about integration tests, which may be instantiating a lot of infrastructure, we could leave a lot of resources hanging around dirty. So Glasser has built in resource management. If something is allocated by a test, whether this is just an exclusive lock on an LPAR, or whether this is a piece of data it's generated, it has the capability to understand and clean up any environment in case of something's gone awry. Test logs and artifacts, I said this earlier, stored in a central location. So in that team environment, I can actually see that when the pipeline failed at 3 a.m., I can just log on to the ecosystem and be like, perfect, I can see why. The safety to run tests in parallel. It provides, if we're using Docker, it would be the individual Docker containers. If we're using Kubernetes, the individual pods. It provides us that safety to run in parallel. We're not going to be clashing. They're running in logically isolated environments, and they're all talking to the same resource management, so they're not conflicting with one another. I've already mentioned the CLI and for the integration with CI/CD, but it really kind of indicates towards that testing as a service. So, and I've mentioned some of the other ones. But the big one that I think a lot of people, which I hope are on the app dev track, will be attracted by, because a test that can understand your application, not just a test tool that can understand all the technologies that your application uses, but a test that can understand your application. And how do we do this? And it goes back to that point that I was on about earlier, that extensibility point, which we call a manager, which from the Glasser team ourselves, we do provide a huge set of managers already. So we have managers that support different platforms, so the zOS and some cloud managers. We have managers that support different middleware like Kix. And we also have managers that support different bits of test technologies like Selenium or Docker even, and JMeter. And it provides that API and that annotation to the tester to interact with. And the whole reason that we designed it like this is for the abstraction of complex work and removing the test boilerplate code, which in the demo, which we're going to flip back to in a minute, I did inherently leave some boilerplate code in there for a reason. I have my concerns whether it's going to work because my laptop is getting rather warm right now, but we'll try it once again. But we have this special type of manager that we call an application manager. And this is something that if you were to take on the Glasser framework, that you would go away and create an application manager for your application. And it has the advantage of providing the Glasser framework and your testers the innate understanding of your application and whatever that may mean. So I've got some examples here that you could just be automating the logon process and how do I interact with a specific bit of my application. Whether this is just going through certain VAMP screens or whatever. But you could also actually have your manager to understand how to deploy your application. You could take it that one step further. Whether you're going to be using like, real zOS LPAR or something, just something else. And we can also manage test data, which is indicating towards my demo in a minute. But the sky's the limit, really. The idea of an application manager is the opportunity to provide certain bits of repeated code, which you may be writing over and over again in all of your tests, to be extracted out of it. And not only does it provide you that extracting out of your test, so you've not got this loads and loads of boilerplate code being copied and pasted around, but you've actually, if something changes, got the opportunity, well, not the opportunity, but you've only got the one place to change it. So it could be something simple as just like one of the 3270 BMS maps has changed subtly. Rather than having to go through thousands and thousands of tests, which may be using that logon process and doing a Control F and replace lots of times, I can just go to my application manager and I can make the change. All the tests. Yes.
Before you go on, there is a question that might be time sensitive. The question is, the script that you are showing, is that auto-generated or manually written and maintained?
One sec, if my keyboard will listen to me. There we go. The script on the right-hand side here. Is that what's being indicated?
I guess so, yeah, because it came in just
the chat.
No, it came in just a second ago, so yeah. Okay.
So this is something that we've created, and we do actually have material that is going through how you'd go about generating a application manager. So this is something that we realized that it's not automatically generated because we don't know what would be automatically generating. Because the idea with the application manager is we're going to be interacting with your application and we don't know how that's going to be. We provide what we call an SPI from all the different managers that you might want to use. So as you can see on screen here, we've got an SPI to the batch manager and the artifact manager, which allows me to submit batch jobs from within my application manager. So I don't have to be doing that in the test again. I can just encapsulate it within a single one. Hopefully you'll see this in a minute when I go back to my, my demonstration. Which is down, so which is good. So yes, this is where demo number 2 comes in, and it is to look at that application manager and potentially highlight one of the reasons why you might want to do it, if in case we didn't cover that properly. So going back to our application, when I did that manual testing, I talked about an account, didn't I? I typed in the digits 1 to 9, and I said this is the account number that I was going to use. And if I was working in a team environment, I might have to go to everyone. All right, everyone, listen, I'm going to be using the account 1, 2, 3, 4, 5, 6, 7, 8, 9. Can please no one else use it? But our application here it has a batch interface to allow us to open up a new account. So what we actually want to start doing now is taking advantage of that and generating an account every time we run a test, because that way I'm creating a unique piece of data that my test can use, and I 100% know that nobody else is going to be using it, because I'm going to go away and I'm going to ask the Glasser framework to go away and generate this piece of data by doing some, ensuring that it doesn't exist, making sure it even maybe conforms to certain standards. Like I want a high buying power, so give me lots of credits, and you can really go to town on what you want your application manager to go away and create. So I'm going to drop back out to the Eclipse that I had open. And if I just move some of these tabs around because I can't hit the X button. Close that. I can't see the Zoom thing. There we go. It's collapsed now. The Zoom thing was over all my tabs. I couldn't see them. So I'm going to go back to my test, and I'm going to very quickly explain how it's working now. So I very easily labeled it here as boilerplate code. But what we were asking the test to do every time it came up was to go away and provision an account by generating a random bit of data, a random account number, ensuring that it doesn't exist already, and then actually submit a batch job to open that account. But let's say I was writing a suite of tests, and my tests were even getting into the hundreds, if not thousands now, of different test classes. And this set of methods here was just something I was copying and pasting, because if I'm testing stuff with accounts, I'm probably going to want a piece, an account to work with, because when we, let's say, considering the fact we're going to be running in parallel, we need to be kind of careful with the data we're using. So I'm just going to comment this out, because the whole point of this now is we want to be generating the data through the Glasser framework, not through the test. And as you can see here, we've got 2 errors which have appeared because I've commented out the provision account method. But thankfully, I'm doing a full proper Blue Peter. Here is one I made earlier. And I have a couple of annotations at the bottom here, which I'm just going to copy paste and move to the top to make them really apparent. Let's just comment them back in. Let's save on that. And do a quick switcheroo with these comments. And we have the same thing between these 2 lines. So I have an account which is going to be provided to me from the Galasa framework. So it's not being generated by the test case this time. It's being generated by the what we call the manager lifecycle inside Galasa. And it's providing it back to the test. And I can then provide certain methods on this object, like account one, like get account number, which then could be used in the same kind of manner as before. Let me just quickly go and make the other change because there is 2 accounts that we use in this test. What do we think? Do we think it's going to work this time if I actually make the effort to build and run it? We will find out. I'm not holding my breath since the fans on my laptop are going pretty bad. So, and that build normally takes like less than a second. There we go, build success. So I'm going to run the test again because I want to see if it works this time. And it'd be really nice if it did because there was something else I wanted to show you. But this is, as I say, the same set of tests that we did before, which was just 3, which I realized I didn't explain what the 3 tests were that we were running before were. Let me just minimize them. So we had a basic assert that the bank was created kind of test. So, I said we were going away and provisioning and binding the environment at runtime. This was just a quick test that I put in place to make sure that, when we've asked you to go log on to my bank terminal, you actually see the Symbiote main menu. Connection was reset. I definitely need to record a version of this demo so when my laptop doesn't melt. But anyway, going forward. And then we had a test here, which was a credit through the web service test, which this actually wasn't that full end-to-end picture. This wasn't interacting with the web application in the front end or the web server. This was actually just communicating directly to that web service from Kix and submitting a SOAP request. It was then that 3rd test, which was doing the end-to-end picture of communicating with the Selenium driver, then the configuration of the web server, and then driving the back end to validate our system of record. So unfortunately, that failed. But I'm actually going to jump forward and go and have a look at the results anyway, because there's one other thing that I just wanted to show you. So another step that we can add now is this inside of our application manager is this provisioning task. So by the way, this is the manager that I created in the Blue Peter style of here's one I made earlier to go provision me some data, which I'm not going to dig into because where there was only like kind of 6 classes inside of here, the logic and the manager lifecycle is a bit outside the scope of this talk. So, but what I've done inside of this manager is I have all the implementation of how to go away and say, create the piece of JCL that's going to open up my batch job. I have got all the logic that generates the random account numbers and checks to make sure that it doesn't already exist. And I'm just passing that generated account back to the test, which some of you might have been like, oh, but that's really kind of dangerous now, because what happens if something's actually going wrong in this phase? But thankfully, we can still pass test artifacts back to the stored artifacts view here. So I can still see that the piece of JCL that it submitted was trying to open an account with that account number, that sort code, and that opening balance. I still have access to these artifacts, even though that I'm running these tests as part of the manager now, generating this data as part of the manager now, rather than inside the test. I think we just got a chat message. Any idea how long it would take a mainframe COBOL developer to become comfortable with writing and maintaining these scripts? That is a fantastic question, and it's something that we've tried really hard to do within Galasa, because when we came forward with this, we hit a lot of concerns with people being like, well, I'm not a Java developer. I don't know how to go away and use things like polymorphism and you know, all these Java technologies to make sure I can write these tests. And we took on that feedback, and the way that we've designed the tests to be written are in a very scripting manner, and the way that we'd expect things in a very logical and very easy to use. So this wasn't part of my demo, but if I just wanted to show you something quickly, let's actually go and interact with the bank terminal. So if I just come in and just write a new line here and say bank terminal, I can use the autocomplete features of my IDE, which then also, if I didn't skip past it, offers me all the interactions that I want to do. So for example, let's just say I want to clear the screen. Ooh, I went past it. On my 3270 screen, so I can clear the screen, and then the next thing I want to do is move the cursor. I forget which one it is. Position the cursor to field containing, I don't know, you know, some sort of log on field. Push tab and is it type? I always forget which one they type it. Type text, and then I could just say, you know, user ID. Idea here being, we tried to make this very fluid and as easy as possible to kind of get your head around how it's all working. So you can even actually make this just look a little prettier, because this is kind of something I like to do when I'm working on 3270 screens, just to make the whole thing look a little nicer. That's only gone red because we've not got an exception, don't worry. And we're nice and clear. And all the objects that are passed back to the Galassa test are in this similar style. You can just use your IDE's, you know, context highlighting and autofilling to help guide you using these objects. So whether this was, you know, the bank terminal like I was doing here, or whether this was the zOS batch. So just to do it again, zOS batch, I want to use that object. I'm just provided with, I just want to submit a job. It can be as easy as that, because we wanted to take the complexity of writing the tests away from the test case itself and allow the user to concentrate on the logic that they're trying to code. Does that answer your question? Perfect. Right. I think I had exhausted the end of that demo. Because we did try and run it, and unfortunately it did fail. You're just going to have to take me as my confident level that this does generally work when I'm not sharing screen or having my laptop turning into a small furnace. And yeah, so let's jump back to the slides. So I just want to start wrapping this up now, because I do want to leave some time for some questions at the end. But one of the things is we are doing this all in open source, which is great news for most people, because you can do what you need to do with Galassa. So when we're talking about these application managers, you can actually just take on the source code that we are writing in Galassa and extend it to do the pieces of work that you need it to do. It also means that we have the community of people around us, which if you want to join any of our community port, by the way, we have a open Slack channel at galassa.slack.com. We have our website at Galassa Dev, and we also have our open GitHub at Galassa-Dev. But we are very community focused, and we have a lot of interaction with people who are using Galassa, whether this is in different environments or for different test cases, because we have some people who are using Galassa to be doing infrastructure testing. Rather than testing an application, they actually want to be logging onto their systems and making sure that Kix resources are enabled and things like that. So we only discovered all of this by talking with our community. So if you are even remotely interested, I would advise that you come along and just join our Slack channel, or come along to our GitHub if you find any problems, because all of our work is out in the open too, in a Slack channel, in a GitHub repository called Project Management, where you can come along and not only just see what work we're working on, but open up any GitHub issues if you find problems with the code. So I do want to leave it there because I want to leave some time for questions. Hopefully there are some, but thank you for coming along to this session. And if you do have any feedback for me, please go to session 2AC.
Thank you, James. Great energy in that presentation. Fabulous. You set the scene, and then you did everything that we want at GSE, setting the scene, and then showed someone how to await the solution. So excellent work.
Thank you.
as we have some time, I can, if someone wants to ask a question personally, I can unmute them, or James can unmute you. So pop in the chat if you've got a question you'd like to ask.
Yes, I'll definitely have to make sure I'm praying into the demo gods a little more for the next session, I think.
Or you could feedback to your manager that you need a better laptop.
I would like to say that that's possible, but I'm already running an i9 with like 32 gig of RAM, so.
So you need a mainframe, your personal mainframe.
that might be asking a little much there. So it looks like I'm going to be giving you all 10 minutes back then.
Well, I think you did such a great job that your presentation covered many of the questions that I had. Maybe on that thing, on the feedback about how long it would take, code snippets in Eclipse are something that I've seen work for people going the other way, who are Java developers learning COBOL, rather than knowing what to type.
Yeah.
Maybe having code snippets. And is there a limit on the version of Eclipse? Do you have to have a specific version of Eclipse?
So you have to have the version of Eclipse of Oxygen and above. Oh no, Photon I think it is now, which is still quite an old version of Eclipse. But yes,
but that is perfect, because that's what IDZ is based on, isn't it? And I'm just thinking, for those customers that have got, the IBM solutions already deployed, Eclipse version, Photon means if it's compatible there, then that's a good one.
So, yeah. The other good thing that I just would like to mention as well, because you mentioned code snippets, is because obviously we developed this all out in the open. When we have our managers repository, we create IVTs to test our managers, which is just essentially using them. So you can actually come along to our GitHub and have a look at all the managers in action, just to get an idea how they're working and how we use them.
So you're at least giving people the, a little bit of help to get started.
Yeah. So, and there are tutorials on our website as well. And the Java, most of the managers Java doc to end. There is, as I say, some walkthrough examples of how to get started with some of the more basic ones.
Right. Well, we've bluffed and still no more questions. So you're right. We're going to give people back some time. So James, excellent work. Thank you very much. And
thank you very much.
Thank you, everyone. Enjoy the rest of GSE. Bye.